Okay, hello everybody, and thank you for inviting me to speak here today. I'm going to go through and talk about our farm because it's the home and the place where we develop and refine our products, and then in particular talk about the DSX no-till drill, which is we have three different products, but that's our seed drill, which is probably the most relevant to the UK market. And then a little bit at the end towards some liquid systems and some development that we're doing with that. So a little bit about Horizon first. The brand was launched in late 2019, early 2020. I've been involved in seed drill manufacture for 15 years, rough 15, 16 years. Previously in France and now here. All of our products have regenerative, sustainable and precision agriculture behind them, so you're not going to see us coming out with a broad main line of power harrows and ploughs and cultivators and stuff like that. That's just not our focus. We're a premium specialist manufacturer, and that's where we're going to stay. We currently employ just under 50 people, and around 60% of the components that go into it come from within a 50-mile radius of, we manufacture the machines 20 miles from here. So there's quite a direct impact on what is a very agricultural area on the local economy from what we're doing. We're growing at 25 to 30% annually at the moment, and plus or minus 70% of what we build goes abroad, so it's again foreign money coming into the local economy, which is good. We do some of the manufacturing ourselves, and some of it is subcontracted. As and when we grow, we'll bring more of that in house, but a lot of it's made in Spalding, Peterborough, Derby, Nottingham, etc., etc. So it's a local built product. We also have a family farm, which is where it all begins, really. We have 300 hectares. It's mostly grade 2, a little bit of grade 1. Before sort of 2019, it was contract farmed by another family member. It was all mostly drained in the 70s, and it's near Holbeach, but not on the nice vegetable salad land, unfortunately. We're on the, as you can see, it's heavier soil. Before we got involved, it was very much plough, power harrowed, tying cultivated, disc cultivated, sort of an intensive conventional cereal system. And we're plus or minus half a metre from sea level. We've brought in a lot of cover crops, companion crops, catch crops, and more diverse rotation, and it's been interesting. When we first our family sort of took the farm back, we had it tested for various different things, but one of them was organic matter. I'm fully aware that organic matter tests are not very reliable, but nevertheless, it was very interesting to sit at the kitchen table with my dad and say, when I got the results, and said, whereabouts did you start farming after World War II, and where did you leave until, actually it was when I was born in 1985, some of the farm was left to grass. And everything in the yellow was ploughed up in the 40s, and the darker fields, particularly this block here, was all like still summer grazing until 85. So it was a real realisation that everything we have been doing, we are to some extent removing carbon from the system or removing organic matter from the soil. And you can tell, particularly those fields at the top there, they're just a lot easier, darker, they grow better crops. And so it fueled my sort of passion to try and at least halt the decline, stabilise, and maybe move back in the opposite direction in terms of not just looking at soil organic matter or carbon, which is the new big thing as to whether we can make money from that or not, but just generally improving soil health. There's people here that know far more about soil health than I do, but that's what we wanted to do. After, I'm going into the 5th year of us stopping intensive inversion, tillage, ploughing, heavy cultivation, and it was really good this summer to actually start to see what was this starting to turn into a more friable topsoil. Now, we've put a lot of muck in over the past 4 to 5 years. We've partnered up with a dairy farm. We do bring some solid digestate into the system, a lot of cover crops. We do bale some straw, do chop some straw. Although my hand was moving around in that, if you go down more than 20, 30 mil, you start to get to the same blocky clay silt that my father and grandfather thought we need power and diesel and thrash this to death and try and get some seed in the ground. It's still there, and it will take my lifetime to try and get that to depth, probably. But it's very good as a farmer to start to see a little bit of change. People can get confused with whether the soil's changing depending on the moisture level of it. It'll often get the farm dry and we'll think, oh God, it's all gone back to concrete as such. But if you try to get it in the same moisture level and actually look at the fields after 5 years, you can start to see some change. And it's the crown jewel of the farm. If you don't have the soil, then we won't grow crops and we won't be profitable. This was an interesting one when we had when Wayne Fleet broke its banks and it was all on the news. I think we had 114 mil, 141 mil in basically a 24-hour or 15-hour period, and our whole farm was flooded. The South Holland drainage system basically was at capacity. That's never happened before. They couldn't. The drains were up to the top of the level. They couldn't pump anything out to sea because the tide was high, etc., etc. And it was really interesting to put a drone up around the area and go, right, everyone says my farm's going to flood around here if we direct drill or we stop doing deep tillage or whatever. So you can go around, put the drone up, and you can look at subsoiled and ploughed land and look at our land. I'm not saying we were any better off, but neither were we any worse off. So it was an interesting one that in that situation, tillage wasn't helping with water infiltration in an extreme event. We went through the painful job of pumping water off the fields with tiny pumps, but we managed to save quite a lot of that, what was basically a direct drilled maize crop. And I believe as the aggregates and soil structure starts to change, our infiltration rates should change, but that remains to be seen. Just a final slide before we go on to machines. I sat in a presentation with some South Americans, and they put this slide up and said about compaction, and farmers always think we have to alleviate compaction. And they did a study, I can't remember if it was in Brazil or Argentina, and the end of the study was actually looking at what farmers were doing in the field to alleviate compaction, and then actually looking at what compaction was there before they did it. And 72% of the compaction was inside the farmer's head, not in the field. So, which is not so much surprising, but it's an amazing waste to do all of that work and waste all that energy and depreciation on machinery and time and labour. And we don't have proper data they obviously don't fully understand what problems they have or they don't have, and so they go out to do the work. But there is a whole industry founded on recreational tillage, so it's an interesting one. So as some of you will know, we don't make conventional equipment like this, and it's somewhat more challenging to be designing and building products like this to work in conditions like this than it is in a more known media. So when we plough or till and power harrow or roll or surface tillage and prepare this nice level, flat, even soil density, it's generally easier to establish a crop. There's less unknowns. Pests are often less. Soil moisture levels are often more consistent. There might be too little moisture, but they're more consistent. So it's generally easier, and I'd say from farmers of the last 50 years, it's easier for them to think about how they're going to establish a crop this way than this. It's a bit more scary for them, or a little bit more fearful, or there's knowledge missing, etc., etc. We generally are dealing with a lot higher residues. The seed beds are a lot less level. The density of the soil is more varied. The moisture level is definitely can be a lot wetter, can be drier. So when you start to design a machine to cope with all of that, it's an awful lot more challenging than what the industry's been used to. So what we're trying to do at Horizon is to get to like planter performance in a high residue no-till situation, which is no easy thing to achieve by any means. Where's the seed drill and planter market headed? The slide that follows this talks a bit more about drills and planters, but there's definitely more autonomy and precision technology coming. There's sensory technology coming that I think will really change the way we're doing things. The whole human coming off the machine completely changes the way that you want to design and control a machine that puts seed into the ground, because if you remove the most intelligent species on Earth, which does, and you let a computer do it, the machine's got to be able to make decisions on its own, and that completely kind of alters a lot of things that you're going to do in design with it. And as Horizon, we're quite small. We're not building our own control systems, but we're partnered with a US company owned by IAgrE called Precision Planting, and we're working with integrating a lot of their technology into our machines to make them more ready for no human, if that makes sense, so that there's a lot more sensory feedback from different parts of the machine. In general, seed drills are growing. It's not my data, but I found it that 2 meters a decade at least. So a farmer that was with a 4-meter drill is now with a 6, and 6s are now with 10s or 12s. So it's constantly getting wider. Will that continue 12, 18, 24? Probably not. I think it will probably come back, and autonomy will mean once you take the human off the seat, time becomes less critical. The machines might get narrow again, but we will see. For us at Horizon, so we have a number of different openers as such. An opener, I mean the element that bolts to the machine, which actually goes into the ground. And this one here would be called a planter, so you would more be looking at those to do sugar beet, maize, or on the continent, soybeans, sunflowers, and other crops that need singulating in the furrow. Here's where we here's a regular, fairly basic disc opener. Here's our disc opener, and here's a precision planting opener with singulation technology and stuff on it. These two things are definitely merging together. You'll see some of the larger European OEMs starting to bring machines out where they're like planter drill hybrids, and I think that is the way the market's going to go, especially on the continent. We don't tend to grow as many singulated seed crops in the UK, so probably won't be a huge market in the UK. But the level of precision in a no-till disc opener is now getting very close to planter performance in terms of uniformity of depth. And really the only thing we're missing on this opener to be able to achieve what this one does is seed singulation and an automatic downforce, which is 2 systems that we will be adding. But it's the level of technology in a seed drill is racing up to be very, very close to what a precision planter is, and that's making it a bit cloudy. So here's our Generation 2 disc opener, which we've been building since the middle of last year. We have a parallelogram. We have a parallelogram at the front, which is giving us 32 centimetres or 30 to 32 centimetres of vertical travel. That means that if you're on a 6, 8, 10 or 12 metre seed drill, the ground could be 30 centimetres higher on the left and 30 centimetres lower on the right, and it would still put seed in the ground at the same depth. It also, because it's a parallelogram, it maintains the dual disc angle that we have throughout the travel. It's quite hard to explain, but if you don't have a parallelogram, the disc angle changes as relative to the position of the pivot. So we wanted to keep a parallelogram. If you look at the bigger manufacturers, all their planters have parallelograms, but they'll normally pull them off the drill. They're more expensive to make. They're more expensive to produce. They're definitely more precise, but we felt that especially with the market heading into this sort of hybrid market, that will keep a parallelogram on the machine. We operate on a dual disc angle, so we are 10 degrees on the vertical and then 7 degrees fore aft, which is, other than one Canadian manufacturer, is unique to us. So why do we have this dual angle, and why don't we have a vertical angle, is something that I'll go on to talk about in the next slide, but it's quite unique to us. It does have occasional drawbacks in certain things, but overall in a no-till scenario it has many advantages, so it's a real crown to our jewel as such. One of the things we did with the Generation 2 opener was we moved the depth setting point to be exactly in line with the seed release, and we redesigned the seed boot, so where the seed is being released is directly in line with where the depth is being set. And that's very important if you're going to start to talk about planter type performance on a drill opener. A lot of farmers don't understand where the depth is set relevant to the seed outlet, so you might have that a foot behind or even in front of the opener. So if you have unlevel ground, you will see seed depth varying along the furrow. We keep it exactly at the outlet. There are other manufacturers that do the same. And then the closing system, we changed on the Generation 2 to an air system. The main reason we changed to air was we'd had a lot of experience with air on planters and stripped tillage row units. And all tractors, most tractors, are now coming with air systems, air brakes, so we can tap into the air brakes and give the operator the ability to change the closing pressure on the furrow edge from sort of 6 to 90 kilos in the cab. When we first built in France tillage machines with springs and pins, in the first 6 months the farmer would change the setting, but after that the pin normally needs a tap and then stops. They just don't adjust it. So no one wants to get out and lay and get hammers out and move pins and et cetera, et cetera. So the more we can do with in-cab controls, the more likely your modern operator is likely to adjust it. Also, what does it give us? It gives us the ability to potentially make that automatic. So if we know what the density of soil is that we're dealing with, then in effect we can let a control system completely make the decision about seed depth, downforce and closing pressure, all linked to an algorithm. So sounds very complicated for a seed drill, right? But remove the human, you need the technology. So that's the sort of the way it's heading. We also added a row cleaner at the front, which is controlled by an air circuit as well. That is to move straw away from the opener so that we don't drop seed onto any residue and create a change in the conditions in the furrow, which will then have an impact on emergence. So all of these things have a reason why they're there. I added this slide in, just why an angled disc at 10 degrees. This graph shows the vertical force required to get a disc into the ground, going from 0, 5, 10, 15 and 20. So you can see from 0 down to 20, the relative vertical force on the opener to get it into the ground, and therefore the weight needed in the machine to get it into the ground is less. And I could never work it out when we started with the DSX. I was looking at all the manufacturers' brochures and weights and stuff and claiming coulter pressures and looking at the ballast on the machine, and it just didn't add up. It's like you have 36 openers at this and the machine weighs 7 tons, but it needs to weigh 10 to do this, and I couldn't work it out. So when we got this information, we directly designed the weight of the machine to encounter the highest hydraulic force that we needed to enter the soil. And we didn't want to make the machine any heavier than it needed to be, because nobody in a wet time wants to drag 12 tons into the field, or 10 or 5 tons more than they need to. So we've directly designed the machine to be ballasted relative to the downforce required to get in a hard dry time. And the fact that we have this advantage being here rather than here means we don't have to make the machine so heavy, basically. And we can achieve deep seed depths even in dry conditions with the machine weights that we advertise. The other problem with a vertical opener is this is actually a vertical furrow from a planter, so it's a double disc opener, not a single disc, but you pretty much get the same type of furrow with a single disc as you do with a double disc, plus or minus. And where you see these nice maize seeds dropped into the base of this furrow, you've then got to try and close that. Now, this picture is actually with the closing system removed, but we've got to close that. We've got to remove air, very important to remove air, otherwise you don't get the same germination time. And we don't want to over-compact it, but we want to have good seed-soil contact. Now, this is a photo taken in the US with lovely soil, which you could nearly put a little tine harrow behind that and close it. But other than that, you have to apply a force either side of this trench. And if you can understand, the angles are working against you to try and close that. So you've got to try and squeeze and pinch. And the problem with squeezing and pinching on a vertical furrow is you generally leave, in the base of the furrow, you leave an air pocket. So it's a real problem, and that's why seed firmers come out on vertical openers. They're trying to firm the seed in the bottom, close it. When we have a 10-degree angle, it's a very basic picture, sorry, but because the trench is more angled, we basically crush and shear this part into the furrow. So we backfill the furrow from an angled flap. And that gives us, with the air pressure as well, gives us the chance to give the operator the ability to create the same environment down the field. So he can pretty much ensure that he's removed the air from the furrow, he's closed it and created an environment to give even emergence. And there's a little video showing how that works. This was into a field that was peas, grazed by sheep. It did have some Roundup, but then it was drilled straight in. And the sheep had really, it doesn't look like it in the video, but the top sort of 10, 20, even 30 mil were really hard, and then it stopped. So it was quite a challenging condition. And conditions like this, you'll hear a lot of people when they transition into no-till, oh, that doesn't work, or it won't work on my land. And unless we give them the systems and the ability to go into conditions like this and do a good job and get even emergence, they will say that direct drilling or no-till won't work, and that's a problem. So when we develop the products, where do we start from? Well, instead of starting and looking at steel, we tried to look at the seed and think, what does it actually need? Well, the seed needs like 35% soil moisture, enough temperature to germinate, depending on what it is, accurate depth, and sufficient seed-to-soil contact. That's what it needs to germinate and get above ground. The most important factor in that building block of yield is the depth at planting. So why is depth so critical? That's an example of 5 and 6.5 centimetres, 1 degree difference in temperature. And just for example, say that your crop needed 10 degrees and there was moisture at 5 centimetres, you could say, well, I'll set the drill at 5 centimetres and we'll go drilling, or at 4, and that'll be fine. But what about soil that's not consistent across the field? So it's always varying in terms of, you might have clay, sand, silt, and so it's always varying. So how do you set the depth of a seed drill when you have this? You kind of need 5, you kind of need 6.5 in places. It can be quite a challenge. If you shallow plant, you'll generally, if you see no rain ahead, you will look and say, well, I'm going to lose it in the top surface, I'll probably go a bit deeper. You can also have problems with, and that happens with our opener and nearly every disc opener on the market, is behind the disc before the seed's in the furrow. You can start to get the soil backfilling into the furrow, which then changes the depth, which then changes emergence. So this is a video of sorry, a lot of this is focused on maize because of the data we have, but this is an experiment on germination and emergence timing on maize in different conditions. So at the different depths, you can see you could then determine, if you did this on your farm before you drilled or planted, you could determine what was the seed depth. Well, if you'd gone too shallow, your crop was never going to grow unless you got rain. If you went in here, you would have been okay, and you equally would have been in through here, but you would have had a more even stand of crop if you'd have been at 6-7 centimetres or 3 inches, 4 inches, than you would have been at 1 or 2. So what can we draw from that is that there's a problem there that the farmer doesn't really know what depth to be at. And so it's easy for me as a manufacturer to talk about this and try and sell them technology, but does it actually pay? So this was a depth study done in Germany in terms of dry mass yield per hectare from maize with different planting depths. So you can see there's quite a difference in yield depending on what depth the operator set. So if you're a farm owner and you send your operator out and he's going to go and spend, I always remember in the US they said if they go out with the largest John Deere planter, which was, I don't know what it's 24 meters wide or something, they're spending something like $35,000 or $40,000 an hour roughly in inputs. Well, if you send that guy out and he sets the thing an inch wrong, he's burnt $500,000 in a day from a wrong decision. So that's why there's systems being developed to make that clearer. So what we do is we'll flag the emergence. So when you plant a crop, we can look at putting flags in the ground. If they're all red, that means they've all come out on the same day. If they're red and blue and white, they've come up 3 days difference, or if there's even more colours involved, you could go up to a week or 2 weeks, and that can determine where the depth was, and then we break that down into yield and see how did it pay. And the different depth settings gave these different revenues. This was in a sugar beet crop, and so 5 centimetres was the most profitable depth to plant your seed at. And you can see the differences in yield. I think this was over 10 metres of hand harvest, depending on where the operator set the drill depth. And this was in a conventional tillage system. And there's the yields. Sorry, I'm skipping through that quite quick. But what do we draw from depth? Well, accuracy of depth is really important. And so when you buy a Horizon DSX, how can I be sure that what George Sly stood here today says that it's going to give me accurate depth? Well, we've moved the position of the depth wheel, but what happens if the depth wheel can't get into the ground, like it's too hard because the customer doesn't set the downforce right? And that's where we would move on to downforce with our opener. So the farmer sat there going, do I put 20 bar or 40 bar or 60 bar? How do I know what to set? Everything you're doing with our opener has a reactive force, so we are pushing down with the closing wheel, we are pushing down with the disc, and we are pushing down with the row cleaner, and for every force there is an equal force the other way. So if we put 300 kilos of downforce on this cylinder, and there's 100, 100, 100, then it will have like 0 kilos in the middle. But all this is far too complicated for a farm operator to try and work out. Like, how does he know how to set? Generally, if you always ask, like if we ask our customers, well, what downforce did you run this year? 40 bar. What downforce did you run this year? 50 bar. We're always like, you should be at 20, 30. Why are you at 40 or 50? Well, because I don't know, so I'll put loads. And then I know it'll get in the ground, which is totally understandable. But what you do then is you compact the side wall of the furrow because you will put 300 kilos of pressure right next to where you're going to plant your seed. So if you're in a conventional tillage situation, you will till the field and plough it and power harrow it and bed till it and whatever you want to do. Then you will go and compact the furrow. It's like a load of energy put in, and then you'll go and make the little plant pot that you're going to put the seed in, you'll go and pack it all down and make the start of the plant's life more difficult. So too much is not good, and too little means that the depth will change. And that's why automating downforce is something that I truly believe in. We've had it on planters for 4 or 5 years. We're shortly releasing it on the drills, along with a whole new control system package, which is a lot more powerful. This is a CTF farm at Grantham, not too far from here. So this is drilling a crop and he is controlled traffic. So you can see his controlled traffic lanes. And what these different colours are depicting is the operator just goes in a field, he does not set any hydraulic downforce, he just says, I'm going to go plant seed at 1.5 inches deep. When he crosses a traffic lane or where a baler's been or whatever, the machine will pick that up with a sensor and automatically adjust the pressure. So he does not have to, it looks after itself. The only thing you have to set is like light, medium or heavy. And that will maintain, and light, medium, heavy is more about maintaining speed. So you could go drilling in hard conditions and go from 9k to 11k, and what you'll start to get is the machine will be bouncing down the field, so you'll have seed depth changing. With the automatic system, it will know that. So it will know that the machine's basically vibrating, and so it will warn the operator to slow down to a speed where it can say, I'm putting seed in the ground at a consistent depth. And so this is one part of the technology that's sort of coming into seed drills, and there's loads more things coming to do with automating other features on it. The labour problem in farming is not going away anytime soon, I'm afraid. Hopefully, I haven't run through that all too quick, but I just had a very quick thing on nutrients. We're one of the only seed drill manufacturers to put liquid on from factory. We did it from the start with the DSX. Nearly 30% of them are leaving with liquid now, which has amazed me. I thought it would be 15, 20 at tops. Ben here helps me with that. And speaking of Ben, we also get faced with customers are now wanting to put different mixes and compost teas and biological solutions to reduce the use of synthetic or conventional fertilizers, which then creates us a problem with inconsistent liquids that tend to block systems that are available on the market today. And we have a basic system which is a flow tube. So if Ben was advising the farmer and asked them to put I won't be rude, weird and wacky compost tea or whatever, it would block the orifices in this system, and that creates a bit of a problem. So we're working on for next year a more advanced system, which is also in collaboration with Precision Planting, which completely removes any mechanical components from the flow control of the liquid. So we can basically pass through soup into the ground. And that means that the farmers can do a lot more home brewing, as they call it. Ben will tell you more about that than me, but it's quite staggering the reduction in synthetic fertilizers being seen by farmers adopting such things. So it's definitely something that we want to be in, because it's a niche and it's a premium, and that's what Horizon's all about. So this whole development of liquid systems is something we're really keen on. And the placement of liquid is also something which is relatively inaccurate today, but we've now got the ability to put liquids on the seed or either side of the seed. So if they're safe to be on the seed and better to be on the seed, we can place them in furrow and on the seed, or either side if it's a pH that doesn't suit the seed or the acidity is too high, because there's now people wanting to put two different types of liquid on at planting, one further away and one in furrow. All of this, from what I've seen, it's easy for me to stand here and say it, 35-40% less use just from placing it better, which if you look at it at 700, 800, 900 pounds a tonne for 1,000 litres, that's a lot per hectare. And do I think liquid technology is going on? This is the final slide. We were involved with a project with a local vegetable farm to Peterborough, and they asked us to put a liquid system, or one of these advanced liquid systems, on their planter, but also their hoe. And they basically send drones over a salad crop, in particular lettuce, this one. And they're actually scanning the head size of the lettuce and looking ahead at saying, Mr. Sainsbury's, I'll only take it between 14 and 17 centimetres. If it's 18 or 5, I won't take it. So they asked us, if we fly the drone map over and measure every single head, basically, on a 2x2 grid. Can our liquid system that we work with precision planting on, can we dose each plant? And we managed to achieve that. So they send a drone over every week or twice a week, and then when the machine goes through, if the lettuce head size is big enough, they won't put any if it's undersized and they want to try and bring the harvest further forward, it will automatically dose those plants individually. We can also do that at planting, so we can deliver fert to each plant location, if that makes sense. So, and what that gave them was a 56% saving in nitrogen in year one, so 30% saving in greenhouse gas, and 24% more product from the field entered the supermarket, which, if you only think that's a piece of technology come in that's cut half the nitrogen, Tesco's and Sainsbury's absolutely love this stuff because they want to tell Mrs. Smith how sustainable their lettuce is on the shelf. But this is the use of the latest and greatest technology to really make a change to the impact that farm's having on the wider environment to put your lettuce on the shelf. So it was a really successful project, and we hope it'll grow into more. It was very hard work and quite complicated to do. Thank you for listening.